Okay, before we do this experiment, I just want to explain how important it is that you use the exact same balance. Each balance will be different, like as you see this one has dents and stuff which could throw the measurement off. And if those differences are kept consistent, it will make your results that much more accurate.
Alright, hello, my name is William Allen. I'm going to show you guys how to do this experiment. First, we tear the scale with nothing on it, so 0. Then you put the empty beaker on it to measure the beaker.
Right, you need to write that number down.
Okay, and that's 30.1.
There's actually less error associated if you don't match that
Okay.
beaker and you subtract.
And then you remove the beaker.
Yeah, I would get a 125. 125 will bring it out of that. And you
Fill this up with a certain amount of water.
And then you get a bunch of lines and then you can break the balance.
Okay. And you want to read it right at the bottom of meniscus, which is right about, let's say, 10.1. Okay. And you fill the speaker up. Place it on the screw. Now we record this and we take the difference between the empty scale, or the empty beaker and the full beaker. Okay. And that is the weight of the water.
Hi, my name is Nathan. Today we're going to be comparing the mass and volume of water. First of all, you want to tear your scale, make sure it's set to 0. Once you've done that, place your beaker in, and then you record what this number is. So that's a 30.244. That way, when you get the weight of the water, you can subtract that number to find the weight of just the water, instead of the water and the beaker. Then you're going to put a random amount of water in there.
And do it for the rest of the
Don't be stingy. And that's about 14.3, I want to say. 14.3. Pour it in there. Slap it in there. And you get about 41.95034. And what you do is you're going to subtract that 30.244 to find the weight of the water. And once you got that, you that's your volume and your mass. You plot them. The mass is what you weighed. The volume is what was the measurement in the graduated cylinder. But when you take your measurement from the cylinder, make sure you take it from the base of the meniscus, just for accuracy's sake. And there you go.
Hi, my name is Drew. Initially is 0 out the balance. Then we need to find out the weight of the beaker, the mass of the beaker.
She said you're supposed to.
Make sure that the door is closed when you take this measurement. The number is 30.1975. We're going to write that down so we can keep up with it. We're going to need that in just a minute. So then, what's that? Okay. Now, we're going to take the beaker back out. We're going to fill our graduated cylinder with a random amount of water. We're going to shoot for a lower amount this time to help with our measurement. It looks like we're 2.5. So we've got about 2.5 milliliters in the graduated cylinder. We're going to transfer that into the beaker. We're going to place the beaker back into the balance. We did not re-zero it. And so now we have a number 36.0331. 36.0331. And what we're going to do here, for time's sake, we're going to skip this step, but we're going to take the difference between these two numbers, and that's going to give us the mass of the water that is actually in the beaker right now. And we'll use that for our measurements later on.
Okay, once you've got all your points for your cylinder, you can go ahead and make a graph. What you want to do is you want to plot out your X and Y axis, volume being on the X and mass being on the Y. And then as you can see, I plotted my first point here. I went across 9.9, and I went up 8.35 to plot my first point. Now my second point is 18.4, so I'd go to about 18.4, and then up to about just under 16. So about here. And my third one is 14.5, about here, because this would be 15, so this would be about 14.5, and up about 13. So there we go. And just draw your line of best fit, and this should be your density. You should be able to guess, say if you had 12, you should be able to guess your mass and volume for any point now.